Okay, hi, this is Will again, and hopefully everybody's looked at the introduction for the box sorter routine. Now we're going to set it up with the PLC SIM. And when you have the FactoryIO and you don't have a PLC, your two options are the ControlIO, which is a program that comes with the FactoryIO, and you can use it standalone just with the FactoryIO. It's a pretty cool program. It only works in functional block diagrams, though no ladder logic. Now what we're going to do is, I didn't want that to happen. Well, this kind of shows you about ControlIO, and you can take a look at that. But that is not what we wanted. We wanted to take a look at the PLC. And before we talked about, you wanted to make sure you had this template. And so you're going to want to do the template for probably V7 1200 V14 zip. And you also have the sample project for any of the versions of TIO Portal. So you can take a look at this program, you can take a look at the one I'm about to do, and make sure you understand that before you try tackling any of the other projects with FactoryIO. But you shouldn't give up on FactoryIO. FactoryIO is a great thing. But when you download it, it's a zip file. Now I've kind of got in my file folder, let me minimize this. If I look in my folders, and I've got too much stuff on here, but if I go on my desktop, I do have a file that's dedicated to the templates, and these are the FactoryIO templates, and these are specifically for the PLC to FactoryIO. You don't need a template if you have the hardware. But I just want to show this. This is the full file folder for the project for any FactoryIO project. This is the particular project file that the TIO Portal runs, but these are the supporting files that you need for it to run. You have a hard time getting it to work with only this file, so make sure that it's the whole folder that you need, not just the file. And that's all I want to show in that. And when you open it, again, this is the template, and all is one function block, and it has a bunch of commands that FactoryIO uses just to be able to talk to the PLC SIM. I'm not quite sure what's in there, but it's good stuff because it seems to work really well. So, and because it is a function block, you'll say, well, where are rungs at the end here? That's because this is a function block and we're looking at it in the function block point of view. So if you right click on here, somewhere down here is switch programming language, and basically you can switch between ladder logic and FBD. If we want to take a look at ladder logic, that'll give us a rung. Now we're going to do the same program with functional block diagrams next time, and we might also do something with structured text if anybody wants to take a look at it. It's might be worthwhile. But anyway, to get started on this program, we came up and we were talking about, we kind of showed pushing the pallet through to the conveyor where you either transfer it right or transfer it left. What you need to do, especially with FactoryIO, you can come up and you can take a look at, you can force the actuators on. You can see that, when I turn that entry conveyor, you can see that, okay, the pallet signal goes high first, and then I get whether it's a high box or low box, those sensors go high. And so you can kind of create this roadmap, is what we like to call it. And while this might not be totally accurate, this tells you, okay, when this pallet goes high, then you turn on this load signal. When this loaded signal goes high, then you turn off these conveyors, this conveyor and this conveyor. That's pretty much where we ended up the first introductory view. But you can see that we're using these, we want something to happen on these edges, and most of these we want something to happen when the signal rises, on the rising edge of the signals. This emitter, what we want is when the emitter signal is complete, we want to turn the conveyor on. So this one will be a falling edge. But what we're going to do in the very next rung here is we're going to define edge triggers. And these are all of the signals that we're going to use based on a rising edge or a falling edge. And if you look in bit logic, what we have in here are we have these gates that look like kind of your normally open type gate, but it has either a P or an N in there. And the P means it's a positive edge, or it's a leading edge. You know, it's going from the no voltage state to a high voltage state, and N is just the opposite. And you can just drag and drop them onto the square, and that'll drop this in here. And what we said was we wanted to, when the emitter went negative, we want to turn on the conveyor. So what I'm going to do here is I'm going to put this output in here, and we've created a signal that is going to be it's called entry conveyor. So we're going to say entry conveyor trigger, and we call it trigger because this is the signal that's going to turn on that conveyor. So what all of these one-shots need is they need a memory location, and they have to have a memory location, so we'll just call this ONS1 for one shot. And now this one, what we have here, and I have an address, but let me show you in the FactoryIO scene. And if you remember from the introduction, we said that all of the, and if we go into drivers, this doesn't show anything, but what our PLC is going to look like is, you know, we have Allen Bradley types, and then we have Siemens types, but we want to go down to PLCSIM, and this gives the inputs and outputs we have to use. Now, if you remember from the introduction, the emitter and the two removers are always turned on by default, and you'll notice they are not shown up in the outputs, which that's a little bit of a problem, but what we can do here is we can just change the configuration. So we need one emitter and two more removers. So if we go into this configuration, and I'm sure it has a maximum number of input-output points, but what we can do is we can just change this from 10, and because the inputs are 14, we're going to make that 14. So now, if we go back to what our driver looks like, now we've got additional I/O here. And the first thing I'm going to do, and I'll tell you why we're doing this, is we're moving the stoplight down here. And then in these open positions, we're going to put the emitter, and we're going to put remover left and remover right. And that's what we need. And this is the input outputs we're going to have. So when we go back here, our emitter is going to be there on Q11. And this ONS, we can just define the tag. And these are just going to be memory bits. And somehow I didn't want both of those up there. I want to define ONS. And computer is really sluggish with both the FactoryIO and the TIA portal. So this will be a global memory, and for global memory we'll take whatever they give us. This entry is also going to be global memory, so we'll just take what they're giving us. And what I'm going to do is I'm going to pause this because it takes a while to do all these, but for every one that we see on here, so where we're using this, so we're using this palette sensor signal, we're using this height strobe, which I'll kind of explain this. Basically, when the palette comes across and the boxes come across and you sense either high or low, you're always going to see a low sensor because as a minimum you're always going to see a low box. But we're going to throw that into a trigger, and we're going to use that as a trigger signal for when we want to look at when it is and when we want to latch in that signal. So we've got the palette sensor, we've got the low sensor, we've got this load signal that we're actually going to call it transfer trigger, since this is where we're doing all the transfer functions. You know, we've got these signals, these add entry and exit, that, you know, again do several things. So we're just going to put those in to, you know, as those are all rising edge, so those will all be a P. And so we're going to put those in, and I'll come back shortly after we've taken care of that. Okay, so all we've done is we've put on all the extra edge triggers here. And so we've got the ones for the entry and exit signals. Now one of the things we want to do is add a new block. And one of the things you want to do is you want to put in a startup block. So this is kind of like the first time through block, and you want to initialize. And what we want to do is we want to make sure all the outputs are initialized to 0 or reset. So for that, we could either use on all these, we could use these reset functions on a number of them, but there's also this reset bit field. And we can reset a number of them at a time. And the very first output we have is the conveyor, entry conveyor, which is 00. And if we look down here, we say how many bits do we want to set. If we look here, we've got all these bits, so those are 12 bits. So we're going to change this to 12. So starting with entry conveyor, we're going to reset 12 bits. Now, it's not in the program yet, but I always have a signal that we call start process. And this will just be defined as a global memory, and again, whatever the system wants to give us is good enough for us for the global memory stuff. We'll define that. And the last thing I want to define is I want to set a bit, and we have on the front panel of our control panel, well, we have the stoplight, and originally I moved the stoplight from this position down here because I actually, when we're off, I need to set that bit. So this 15 is one that I need to set. So this will be the stop lamp. So those are the conditions I want, and I guess one thing I'm thinking of is I'm also going to have this counter that counts how many pallets we processed. So I want to make sure that when we start up, that that is going to be a 0. And since I've defined all the inputs and outputs at this point, I called it pallets processed. And one of the things you should do before you start writing the code with FactoryIO, just so you have it right, is go in here and you have all the inputs and outputs from your FactoryIO, is just make sure all these inputs and outputs are in there correctly, even if you don't use them, in your PLC tags. And that way all you'll have to do is pretty much add in logic, but global memory, which automatically picks them. You have to have the exact correct address for all these. For instance, if you wanted to put in your high sensor, if you didn't have it in there and you put in 00, but then you put in the loaded signal, the PLC program is automatically going to call it 01 because it picks the next open item. So if you haven't already put these addresses in, it kind of automatically picks the next open one. And if you put them in here before you start programming, you'll be in a little better shape. At least that's what I've found out. So you can put tags in, and there's this PLC tags, and you can say show all tags. And this will show all the tags that we have, and I've basically got all the inputs and outputs. And then I've got these ONS signals, as well as the memory signals that go with them. If you wanted to look at them in order, you can look at them in alphabetical order, or you can look at them in address type order. And if we look at this, now this gives all the inputs. Spun it away a little bit. Then it'll give you all the outputs, and actually these are in reverse order now. But it gives you all the inputs, all the outputs, and you can just make sure that these are all correct. So we've got our inputs, we've got our outputs, and then we've got these memory bits that we used as part of the ONS structure. So we're ready to write code at this point. And the first thing we're going to do is we're going to go back to the main program, and we're going to do some StartStop Logic. And if we can get back into the main program, we're going to start into a new network. And you'll see that, like right now, there's nothing beyond network 3. As soon as we put in this gate in here, automatically a network 4 will appear. So you aren't limited. As soon as you start one in this network, there'll be another network afterwards to go with. So right now there's a network 4. So what we're going to do is our normal start stop push button, start push button, stop push button, and this is going to be our start process. And what we're going to do is we're going to latch this in. So there's two ways to put in another circuit. You can either drop it in if it's at the bottom of the circuit, and I just want this to be my start process. And when I put in the actual location where I'm branching to, I can put it to either one of these squares. Now I only want it to branch around the push button, so we'll leave that at that. Now for my emitter, what I want to do is I want to derive that from my start process and my start push button. And this is, I don't know, kind of easy way to make the first emitter. And this is going to be my emitter signal. Now that'll be for my first time around. Now I'm going to have another second time around emitter, so I am going to call that, let's see, my second emitter. Now for that, I'm going to give it a global memory. And see how it automatically assumes, in a lot of cases, not all the time, but assumes it's global memory, and it gives me the next available one. You have to be careful when you're doing that with your inputs and outputs if you're not going in order. But for the global memory, I really don't care what it defines for those global memories. Have to be a little more careful, like, for instance, if I went directly from start push button at 1.1 and I put in the stop, it's actually address 1.2. The PLC, from its own reasoning, if everything was wide open, would make it 1.1. And actually that 1.1 is the reset push button. So just just understand that and realize that you have to, well, that's the reason that you should manually put in everything at the beginning. So well, that's all we can put in for our start logic. So we can make this so we'll call that start and emitter logic. And for this one, we'll just say these are our input conveyor. And this will be the logic that kind of took us up to the very first introduction video. So this one is going to be, and I think we call it entry conveyor trigger. Yep. And that's actually going to turn on the entry conveyor. Okay, and that's going to be latched. And come on. And now what's going to turn that off is that transfer trigger. So that's actually going to turn off that signal here. And we can just bring that up here and call that the transfer trigger. And we're going to do the exact same thing for the load conveyor. So here, what we're going to do, well, first what we're going to do is we're going to double click here. I had been pulling a rung right below it, but what I want to do is I want to highlight the rung. I want to do this, which is open a branch, and if I double click that, it's going to put a stub, and that's kind of a convenient little feature. So I want to copy this, and I'm going to put it down here. And now here, what we said that was going to be, it was going to be the load conveyor trigger. And this is going to be the load conveyor. And right here, because this is going to be the load conveyor again. And again, this will be the same transfer trigger is going to unlatch it. So I think we're good there for that input conveyor. Now, what we're going to do is we're going to determine the height. So here, what we said is we've got this signal that we call height strobe. And then what we say is for the low box, well, first, okay. For the low box, the low sensor will be on, and the high sensor will be off. Now, I haven't put this high sensor code in, or I haven't put this tag in yet because I want to show you something that when I was putting in the tags, I came up with this. And before I do that, I'm just going to say this is going to be, and this will be for our low box bit. And this is going to be a latching bit that is going to, because remember what happens is those sensors, it sees the box, but then the box goes away before it gets in the transfer position, so we have to latch it. So this one is going to be a memory bit. And that's fine. Now let's take a look at this high sensor. So when I was initially putting in everything, the high sensor was on input 0.0. So we're going to give that, we're going to define that tag as 0, input 00. Okay. Well, I guess I must have erased it. Originally when I did this, there were 3 tags by default in this program, and one was 00, one was 01, and one was output Q1, 00. And if you, well, let me just show you what happens. And I guess I just deleted it completely and didn't put it back. I had meant to put it back. If I have a duplicate tag anytime that there's the same tag with 2 names, I'll just add a tag. And I'll just call this tag 1. And I'll give it the same 00. So you can see it gave it the next available, which it thinks is 13. And it is going to be 13. But if I give it 00, what it's going to do is it's going to come up and it's going to show these in this color, which is kind of a warning. But if I look back on my program where I would normally put it in, that tag is going to show up, my high sensor is going to show up in this same, I don't know, yellowish warning color. So you can go back to your PLC tags and show all tags, and you can see where the duplicate is, and we know it's this one. So I'm just going to delete that, and now everything's okay. But that's another reason to when you're starting out, take a look at your tags and then put all your inputs and outputs, and make sure that there aren't, when you open a brand new TIA portal, there should be no tags at all in there. You're creating all the tags. I'm not quite sure why those tags were in there. I have, well, I mean, I don't know, but I'm guessing it has something to do with the template and the original startup that FactoryIO is assuming, but I'm not sure of that. So if we go back here, now we have to make this high sensor, we have to, or this low box bit, we have to also latch that in, because this does have to be latched in. So we'll put the low box bit. And what's going to unlatch this? And if we look here on a timing diagram, this high box bit is unlatched by this at entry signal. So, and remember, for these, the low box is going, we said that from the beginning, low boxes are going to the right or down in the screen. High boxes are going up or left in the screen. So this is a low box. So this is going to be the right entry trigger. And that is going to be for our low box. Now, for the high box, we're just going to, once again, we're going to copy this. And, you know, for the low box, high box, right, left type part, we can pretty much just duplicate what we have. So we do that. We highlight this. And if we double click this, we should get our stub. Okay. So we're going to copy all these, Control C, put them down here, Control V. And now what we have to do is we just have to change this from normally closed to normally open. So if we highlight just this, there's this little triangle orange in the corner, and if you pull that down, you can change the type of gate. And we're going to change this from low box bit to high box bit. And got to give that a memory bit, and so it's going to automatically give it next available. This will be the high box bit, and what we have to do is we have to change this from the right entry to left entry trigger. Okay, so now we've got everything ready for transfer, and now we just have to do the transfer and turn on the output conveyors. So we're going to, for low box, we're going to start out with our latched low box bit. Well, first we're going to put in here our transfer trigger, I guess. So it's transfer trigger and low box bit will be, so this will be the low box bit. And what the output signal for that is going to be transfer to the right. I think it is called transfer right. And that's going to be, again, a seal-in circuit. So it'll be transfer right. And what unlatches that is going to be the entry trigger again. So this one is going to be the entry trigger. So it'll be right entry. And again, we're going to just highlight that, double click that for our stub. We'll copy all these, paste it down there, and then change from right to left. So transfer trigger is correct, but this will be high box bit. This will be transfer left. This will be transfer left. And this will be the left entry. Okay, so that gets us to the transfer. Now, at the same time, we also want to turn on the conveyors. And these will be the same setup, except rather than, and it'll be the conveyor rather than transfer, but then this will rather be the right entry or the left entry. These will be the right exit and the left exit triggers. So we're going to highlight that again, put in our stub, hopefully. Okay, and now, and you know, if can't get everything in the screen, you can use this little sliding scale to kind of change the view. You can make it bigger, you can make it smaller, and now I can easily highlight what I need, copy it, paste it, and maybe I'll make it a little bigger again. So we've got our transfer. So we've got transfer right, transfer left. Now this is going to be conveyor right. And this will be conveyor left. Okay, and these are going to be the same. It's going to be high box, low box. This will be conveyor right. And this will be right exit. And same thing here, this will be conveyor left. And left exit. Okay, so I think we are almost done. Let's take a look at here again. So now we've got, here's where we're at right now with this left exit. So this turns this off, is where we've gotten here. Now this thing also has to form our second box and count how many boxes we've processed. Now here for the remover, we don't really need the edge trigger signal. We need this at exit signal. What we're going to do is just flip it. So for the, I guess, remover, I don't know, remover and new emitter. Remover and new emitter. So what we're going to start out with, we're going to say, because we've got to flip it, we'll put it in here, we'll say at right, at right exit. And this just goes out here to remover right. And we'll do the same thing for at left exit. Left exit. And remover left. Okay, and then for our last stuff we're going to put in here, put this in here, and this one will be right exit trigger. And I guess I'll put another one down here, and this will be left exit trigger. And what we're going to do, and I really like this little thing that the Siemens has for timer operations. There's this one, you see the timer on, timer off, and they have a retentive timer. They also have this TP, which is a pulse timer, and this thing is great because it'll put out no matter what, whatever type of pulse you want. So right here we're going to say, let's say half second pulse, which is 500, everything's in milliseconds, so that's half of a second. Now we want it to be whether it's either the right or left trigger that's going to put out a new pulse. And we said that this output, and so this output is going to be high while it's counting. So this is kind of like a timer trigger or timer timing signal, and we called that one second emitter. And the last thing we're going to have is a counter, and it's basically going to be the circuit, but instead of a timer, it's going to be a counter. So I want to highlight this. I want to create my stub. Got one too many. And we're going to highlight these. A little exuberant there. Put that down there. And now, and one of the things that if you are doing timers, you cannot just copy and paste. like I just did. Now I am going to change this one to a timer, but because these have data blocks associated with them, both of them have the same data blocks. So if they're two different timers, you gotta have two different data blocks. So really what you need to do is you can't copy and paste. If you wanted another one of these timers, you'd have to pull another one from here. Now we aren't really doing that. What we're going to do is we're going to put a counter in here. Counters, and this will have the same type of data block associated with it, so you can't copy counters, can't copy timers. And this, don't really care what we're counting up to. Now in real life maybe you'd want to know when your count was like 50 or 100. I mean, I don't know. And we can put in, for the reset value, we're going to put in the reset push button. And I think the final thing is, we call this pallets processed. And that should be fairly good, I think. So what we're going to do is we're going to run it through the compile window. And if we have any errors, they'll show up down here, but there's 0 errors, 0 warnings, which is a good sign. Now, what we want to do is we want to go into Online Simulation Start. And it gives us a couple messages that say we're simulating this. We know we are, so that's okay. And then we'll start going through the download process. And so when we, well, we're got a couple seconds here, and you can see it's gone through the process of starting to load. But the next, here you do need to start the search for the PLC. It should have that's the address it should be looking for. I know everything's simulated, but it should be looking for that. After it finds it, and after we get the green check mark, we can say load. Well, I was going to say we're just going to get rid of all these rungs that have ladder logic, and we're just going to do everything in function block diagrams, and you can take a look at that. Once you take a look at it, it's fairly obvious what we're doing, especially if you have any familiarity with digital logic. It makes a lot of sense. So now it's ready to load, but this says no action. But if we highlight it, it has this pull down, it says start module. And over here you see this is amber. That means it's in the stop mode. It needs to be green when it's in the run mode. So if we say start module and finish, this thing will start blinking. And that's actually what an actual physical PLC does. So now it's in the run mode. And we can just highlight our PLC, and we can say we're going to go online. And we will monitor this on off. And now we can go to the FactoryIO. Now here we can get rid of that palette. Now we want to make sure and clear the dock tags. And well, first we want to dock all the tags. And you know, this still has these forced on, so we're going to release these. You have to make sure when you're running from the PLC for those tags that you release them. And you know, you can tell when they're on or not. I'm just going to turn this left one back on. I'm going to force that on. These emitters, they'll be lit up, so if you come to this page and it's lit up, you know it's forced on if you're initially starting out. So let's see, we can close this for a second. And now we want to go into the drivers and see how we're set up. So we're in PLCSIM. If we go into configuration, S1200, which is where we should be. Now we have to go in, we have to connect up to our PLC. This will take a few seconds, but you get a green check mark over here. And once we connect up here, hopefully, you'll see the stop light turn on when it's connected up, because this does need to be on when we're first starting up. and that's one of the indications that everything's in good shape. Not quite sure why that conveyor entry is on there. Let me stop the PLC for a second and return it on. Well, there might be a little bug in here. Well, we're not in the run mode anyway, so let me stop this. Let me put this in run mode and reset this. Sometimes the little playing between the systems, it's kind of hard to know what's going on. Well, it didn't want to do that. Let's take a look at these stock tags again. Conveyor entry is on. Let's reset this. Because this output is on, I'm going to stop the PLC. When I rerun it, because it should go on the first time through here, it should have that cleared, but it doesn't. So let's take a look just at that conveyor entry signal. So conveyor entry. And maybe what we need to do for that signal, let's take a look at this. So our signal is off, we're not on there, but this is turning on, which means somehow we're getting a trigger signal. So, okay, so what I'm going to do really quick is I am going to make sure that we don't get this at startup, and I probably should have this in here anyway, but I am going to put in my start process signal here. Now when I make changes like this, because we're already connected up, it should put this into the system. Now all I have to do is really download it. We'll go into a quicker type of downloading process. So now if we load it, and when it gets loaded, they all go green, and we'll turn this on now. Let's stop it and run it again. Okay, so now everything's off. I think we're in good shape, and you know, this is one of the things that looks good on paper, but when you put it onto the stuff, it doesn't quite work the way you think it is. So now I'm going to reset this. We're going to take a look at this again. I think we're in good shape though, just because of the way that worked. So we're in run mode. That's the stoplight is on. And if I turn this on, hopefully, oh, let's see, one more thing when I was thinking about it here, since we're doing the start process. So we have this start process, and one more thing I put in here, because I was looking at that. We have the start light and stop light. So when we go into the start process, we also want to turn on the start light. So our start lamp. But we also want to do is we want to turn off the stop lamp. And so for that, another thing that Siemens has for its bit logic is you can come on, go up here and out here they have regular coil, looks like this, but then the negated coil, which is a negate assignment, is going to make the opposite. So if this is a 1, this is a 0, and we'll make this, instead of the start lamp, we'll make this a stop lamp. was just thinking about that when I was looking at that enclosure, and it didn't have, well, it had the stop lamp on, and it would have stayed on when we turned the machine on if we didn't put that in there. And we also want the start lamp to come on. So we'll load it, and hopefully this one will be alright. And okay, so now you can see here that the stop lamp is on. When we start up, it will go into start process, and then the start lamp will come on when we are looking at the machine here. So I'll just reset that quick. I'll clear this guy for a second. You can see that our stop lamp is on, and now when I hit it, hopefully things are going to run pretty well. And let's take a look at what happens here. It's transferring. That's a tall box, and that looks pretty good. So when it fully vanishes, another one will show up here. And there we go. And now if you wanted to, you can kind of dock all the tags. If you want to see how your logic is functioning, this is one of the ways you can kind of evaluate if your signals are turning on and off as you expect. You can also see that this is counting. Now you'll notice that there's a small little delay. Well, let me show you. There's a small little delay when the box shows, and well, not much when it starts running. I thought there was a delay there, but that was pretty fast. This is a small box, so it should come down this way. And it should keep counting like this. This program looks like it's fairly good. If you get used to it, you can kind of try to work the different shots if you want to make a nice little video of it as to what's going on. You can also, for something like this, since it's fairly slow, usually we turn the speed down when we want to see what's going on with the sensors, but likewise for something like this you can turn it up a little faster if you want to see it work a little quicker. That's a small box. And you can take different looks at it. The one that's happening right head on, and here you can actually, if you get close enough, you can actually see what's going on with this. This is actually a chain transfer, so it lifts up and then it pulls it one direction or the other direction. So you can see it raise up, and then it's got a chain that actually pulls it across. And you sometimes, you actually see that in factories for when they want to do this type of thing. It'll kind of raise it up and push it one way or pull it one way or the other. So anyway, that's the first part of the first of three. The next one we'll do function block diagrams. And so what we're going to start out with is we're still going to keep all these triggers in. There's no reason to get rid of them. And actually, when you're combining logic, you're going to have some that's going to be regular ladder logic, and then some that's going to be functional block. But the next part of it, we're just going to get rid of all these networks from after the edge triggers, and we're going to make all of these in functional block diagrams. And because of what we were showing before with how you can change the language, you can take a look at what the block looks like in ladder logic versus functional block diagrams, and that may be helpful for giving you a little insight for the differences between them. So anyway, until next time, try this out. Again, you can try it either this way, or FactoryIO does give you in their tutorials, they give you their answer to the problem. If you look again back in here, they have samples. So if you go in here for the Siemens stuff, if it wants to show us that, well, maybe not, but you can look at their version of how they solve the problem. And again, for a problem like this, there's always 6 correct answers, and there's a lot of them that are wrong. But they do have the sample program, so you can either try to do it this way, or you can take a look at how they do it. So until next time, we'll see you. and try it out. If you can do this type of project, there's a lot more you can do with it. The FactoryIO.